Hello everyone and welcome. I'm excited to kick off today's presentation. My name is Faiz Mohammed and I'll be guiding you through our discussion on friction. This is the cover slide, so I just want to give you a quick overview. We'll explore what friction is, how it affects us, and some interesting insights into this fundamental force. I'm glad you're here, and I look forward to sharing some valuable information with you. Let's get started. Let's take a closer look at the contents of this presentation. We start with force of friction, which is a fundamental force that acts between surfaces in contact. Moving on, we see that friction is sometimes useful. It plays a crucial role in our daily lives, like enabling us to walk without slipping or allowing cars to grip the road. Next, we consider factors affecting friction. Various elements such as surface roughness, the materials involved, and the normal force influence how much friction is generated. Then, we explore the cause of friction, which primarily comes from the microscopic irregularities between surfaces that interlock and resist motion. The types of friction include static friction, which prevents movement, and kinetic friction, which opposes motion once objects are sliding past each other. Increasing friction can be beneficial in situations where grip is needed, but sometimes it's a challenge. That leads us to reducing friction, which is often desirable to save energy or prevent wear and tear. Finally, friction is sometimes undesirable, especially when it causes unnecessary resistance or damage. Understanding these aspects helps us control friction effectively in various applications. The force of friction is essentially the force that works against the motion of an object as it moves over a surface. It always acts between the object itself and the surface it's moving on. For example, when you roll a ball on the ground, you'll notice it gradually slows down and eventually stops. That's because of the force of friction between the ball and the ground. Similarly, if you're riding a bicycle and stop pedaling, the bike slowly comes to a stop. That slowdown happens because of the friction between the wheels and the road. So the key idea here is that friction always opposes motion. It's like a resisting force that tries to prevent or slow down movement. This concept ties into our broader discussion of forces because friction plays a crucial role in many everyday situations, helping us understand how objects move and stop. Let's take a closer look at the factors that affect friction. Friction depends mainly on two things. First, the nature of the surfaces in contact. This means how rough or smooth those surfaces are. The smoother the surfaces, the less friction there will be. Think about sliding a book on a polished table versus a rough wooden surface. The polished table allows the book to slide more easily. Second, how hard the surfaces press together. The greater the pressure, the more friction you'll experience. So if you press two surfaces tightly together, they will resist movement more than if they are just touching lightly. Overall, understanding these factors helps us see why some surfaces slide easily while others resist movement, which is key to many practical applications in everyday life and engineering. Let's talk about the roughness of surfaces and how it affects friction. When a surface is rough, it has more irregularities and bumps. These bumps and irregularities create more contact points between two surfaces. As a result, there's increased resistance when they slide against each other. In other words, friction tends to be higher on rough surfaces because of these additional contact points. This is an important concept because it helps us understand why some materials or surfaces generate more friction than others. Connecting this to the overall theme, recognizing the role of surface roughness can help us better control friction in practical applications, whether we're designing machines or choosing materials for specific purposes. Let's talk about how pressure affects friction. When surfaces are pressed harder together, the friction between them increases. Think of pushing a heavy box. The more you press down, the more resistance you feel. Conversely, if the surfaces are not pressed as hard, the friction decreases. So, in general, the amount of force pressing surfaces together directly influences how much friction there is. This is an important concept because it shows us that friction isn't just about the roughness of surfaces, but also about how tightly they're pressed together. Understanding this helps us better control and predict friction in various everyday situations and engineering applications. Let's talk about the cause of friction. Friction happens because of the interlocking of irregularities between two surfaces that are in contact. Now, when surfaces are smooth, they still have tiny irregularities, but these are very small. On the other hand, rough surfaces have larger irregularities, which means they stick together more. So, the rougher the surface, the greater the force of friction. This idea helps us understand why some materials resist motion more than others, which is a key point in understanding how friction impacts everyday objects and machinery. Now, let's explore the different types of friction. There are three main types that we need to understand. First, static friction. This is the force that acts on an object when it's at rest, preventing it from starting to move. It's what keeps an object from sliding off a surface until a force is strong enough to overcome it. Next, we have sliding friction. This occurs when an object is actually sliding over a surface. Interestingly, sliding friction is usually slightly less than static friction, which means it takes a bit less force to keep an object sliding once it has already started moving. Finally, there's rolling friction. This happens when an object rolls over a surface, like a wheel or a ball. Rolling friction is even less than sliding or static friction, which is why wheels are so efficient for movement. Connecting this to the overall theme, understanding these different types of friction helps us see how objects move and what forces resist that movement. Recognizing which type of friction is at play can help us design better machines and understand everyday phenomena more clearly. Friction is actually very useful in many of our daily activities. For example, when we walk, it's the friction between our feet and the ground that allows us to stay balanced and move forward without slipping. Without that friction, walking would be almost impossible. Another great example is writing on a blackboard. The friction between the chalk and the blackboard is what allows us to make clear, visible marks. If there was no friction, the chalk would just slide off the surface and we wouldn't be able to write. Friction also plays a crucial role in construction. When bricks are laid, the friction between the bricks helps them stay in place and build strong structures. It's a key factor in ensuring stability and safety. And of course, when we write with a pen or pencil on paper, friction is what keeps the ink or lead in contact with the surface. Without that friction, our writing would be very difficult, and the marks wouldn't stay on the paper. Finally, friction between tires and the road is essential for automobiles. It gives the tires grip, allowing cars to accelerate, turn, and stop safely. So, despite sometimes being a nuisance, friction is actually an essential part of many everyday activities. Friction, while essential for many functions, can sometimes be a real problem. For example, the soles of shoes wear out over time because of constant friction with the ground. Similarly, in places like railway stations, the steps of staircases and footbridges experience wear and tear due to friction from foot traffic. It's also interesting to note that tires on bicycles and automobiles gradually wear down as they roll against the road, again because of friction. And even tools we use daily, like knives and razors, lose their sharp edges over time because of friction during cutting. So, while friction is vital for movement and grip, it's important to recognize that it can also cause parts to degrade or wear out. This helps us understand the importance of managing friction in various applications to avoid unnecessary damage. When we talk about increasing friction, one of the main ways to do that is by making the surfaces in contact rougher. For example, if you look at the soles of shoes, they're often grooved. These grooves help grip the floor better, making walking or running safer and more stable. Similarly, in vehicles, the brake pads are designed to be rough. This roughness ensures that when you press the brakes, the vehicle stops effectively without slipping. Tires are another great example. They have tread patterns that increase their grip on the road, especially in wet or slippery conditions. These treads channel water away and create more contact with the surface, improving control. And even in sports, like gymnastics, athletes often apply a coarse substance, sometimes chalk or grip powder, on their hands. This helps them hold onto bars or rings more securely by increasing friction. All these examples show how increasing surface roughness is a practical way to boost friction, which is crucial for safety, control, and performance across many activities. This idea ties back to our overall discussion of how friction can be managed and applied in real-world situations. Let's talk about how we can reduce friction, which is essential for making machines and movements smoother. One common method is to use lubricants like powders, oils, or greases. These substances create a thin layer between moving parts, minimizing resistance. For example, applying oil or grease between machine parts helps them move more easily and reduces wear and tear. Another effective way is to use ball bearings. These small balls sit between moving parts, allowing them to roll smoothly instead of sliding, which significantly cuts down friction. You'll find ball bearings in many devices like ceiling fans, bicycles, and cars because they improve efficiency and longevity. Wheels are also a classic solution to reduce friction, especially in vehicles. They allow us to roll rather than slide, making transportation much easier. Think about luggage bags. Those rollers help us move heavy loads effortlessly by reducing direct contact and friction with the ground. Additionally, sprinkling powder on a carom board is a simple way to decrease friction, helping the coins glide smoothly. Rollers are used in various places, like in luggage or conveyor belts, to facilitate smooth movement. In summary, whether it's through lubricants, ball bearings, wheels, or rollers, reducing friction is all about making movement easier, more efficient, and less wear-prone. These methods are all connected to the overall theme of making mechanical work smoother and more effective. Now, let's talk about fluid friction. Fluid friction is the force that liquids and gases exert when objects move through them. It's what makes moving through water or air more challenging than moving through a solid. The amount of fluid friction depends on a few key factors. First is the speed of the object. Faster movement generally means more friction. For example, birds flying in the air have streamlined bodies, which helps reduce this friction and makes flying easier. Next, the shape of the object plays a big role. Fishes living in water also have streamlined bodies, which helps them glide smoothly and minimizes resistance. And finally, the nature of the fluid itself matters. Think about airplanes and spacecraft. They're designed with streamlined shapes to cut through the air or space efficiently, reducing fluid friction and making travel smoother and more energy efficient. So, in essence, whether it's a bird, a fish, or a spacecraft, designing for reduced fluid friction is all about streamlining the shape and considering the fluid environment to optimize movement.